trinomials of the form ax squared plus bx plus c. The difference between this lesson and the lesson prior to this one is that the lesson prior had a leading coefficient of 1, so a was 1. Today, a will not be 1. A will be some other number besides 1. So we're going to figure out what do we do if we have a leading coefficient besides 1. So for instance, you should see this. A is going to be greater than 1. And if it's ever negative, then we would factor out the negative so that a ends up being greater than 1, okay? So I don't want you to think because a is negative, you can't factor it. You would just factor out the negative on the negative 1 to make the trinomial positive. All right, but don't worry about that. The main thing is we're factoring trinomials that have an a value that's other than 1. You're still going to use an x method, but it's going to be a different x method. The one prior to, you just put the constant, which was c in the top of the x and b in the bottom of the x. All right, but let's get into how we factor these where your leading coefficient is something other than 1. All right, and so it tells us to always look for GCF first before factoring any polynomial. So now I want to make sure before I do anything, before I even teach you to solve these or factor these trinomials that have a leading coefficient other than 1, before that, what you would always do before you factor in any case is look for a GCF. So I'm going to put some of those in this lesson today where you have to look for the GCF first and then use another method to factor. And that's very important. That's always the first thing. All right, now let's go down and look at the rest of the notes. So the strategy for factoring trinomials of the form ax, should say ax squared. Let me put that on there. Of the form ax squared plus bx plus c, where the leading coefficient is greater than 1, are these steps here at the bottom, and there are actually 4 of those. So let's go through them. All right, so number 1, again, I said always look for what first? So we're always going to be looking for a GCF first, okay? Always. Then what you'll do is proceed to step 2. Use the following form of the x method. Okay, notice this x method right here is very different from the one we did in the previous lesson. In the previous lesson, the top of the x only was a c. In this lesson, you're going to have a times c, and you're saying, well, what is a? Remember, a was the leading coefficient. So you're going to multiply your leading coefficient by your constant and put that number or that product here in the top. B still goes in the bottom. B is your middle term. It will still go in the bottom of the x. It still represents your sum, but the main difference is this part right here. Instead of just being c in the top of the x, is the product of a times c, a being your leading coefficient. All right, and then let's just go on down so we can look at the rest of the notes. All right, so it tells us after we put those numbers in our x, you will need to look for 2 numbers that have the same product as a times c, yet produce the sum equivalent to b. And then you write those numbers on the sides of the x. And this will make more sense once I get into an example. Afterward, you're going to rewrite your polynomial by replacing the middle term only with the numbers on the sides of the x. So the middle term only gets replaced with the numbers on the sides of the x. Now, in the prior lesson, we took the numbers on the sides of the x and they went into the factors, the actual factors. When your leading coefficient is something greater than 1, those numbers on the sides of the x will not go into the actual factors. Those numbers on the sides of the x, when your leading coefficient is something greater than 1, will only replace the middle term. Okay, so that's how you use the numbers on the sides of the x when your leading coefficient is something other than 1. Then it says keep the first and last terms term in the trinomial. So basically, guys, this is what it's going to look like. You'll have, let me get off of there. If you have ax squared plus bx plus c, then what you'll end up with is you'll end up replacing this middle term with, I don't know, some other numbers, but I don't want to say numbers. You're using those numbers to help rewrite this middle term. So you're going to end up with ax squared, and those numbers on the sides of the x become the coefficients for your x variable in the middle term. So for instance, you have ax squared plus some coefficient times x, whatever that number is, plus some other coefficient times x plus c. So this middle term gets broken up. It's broken up into something, some x plus some other x, okay? All right, and it may not be plus, these middle signs may be minuses. It all depends on if the middle term is positive or negative anyway. So in other words, what you'll end up with is you're going to end up with exactly 1, 2, 3, 4 terms. And you all should know that if you break the middle term down into 2 terms and you already have 2 other terms there, that makes 4 terms. But you all should already know if you have 4 terms, then you can just factor by grouping. So basically step 2 and step 3 changes this in a way so that you can factor by grouping, which is the next step. So on this next example, it says, well, not the next step, it says factor by grouping. That's because step 3 has allowed you to create 1, 2, 3, 4 terms. And as long as you have 4 terms, you can factor by grouping. All right, let's look at some examples because those were a lot of rules. So it's best just to watch me doing the examples and then you'll pick up the rules, okay? So the very first thing was look for a GCF, okay? Do we have a GCF among all 3? So we have 3x squared, 5x, and 12. Is there a GCF between all of those? No, there is no GCF. And then 2 is to do the x method, okay? Now this x method is different. Remember, at the top of the x, you're going to have a times c, and here you're going to have b. So you're going to look here, a is 3, b is 5, and c is negative 12. So if I put a times c at the top of the x, that means I'm putting negative 36 at the top of the x. And b still goes in the bottom. It's 5. Okay, so now you're going to think about it the same way we did those sum and product puzzles to figure out what numbers go on the side of the x. All right, so I know that negative 36 is negative, so that means the signs have to be different. I have a negative times a positive. All right, but if you look at this bottom number, it's positive, which tells me that the largest number needs to be a positive, okay? All right, so with that being said, I'm thinking about 2 numbers that give me negative 36, but the signs are different. But yet add, and I get positive 5. So automatically, I'm thinking 9 times negative 4. Well, that gives me negative 36. Let me write that a little better. And then 9 plus negative 4 equals 5. Okay, so we have 9 and negative 4. You are not going to use those numbers in your factors. So I don't want to see anybody writing x plus 9, x minus 4, because your leading coefficient is not 1. Your leading coefficient is actually a 3. So again, I told you if your leading coefficient is something other than a 1, you cannot use these numbers in your factor. So you can't go x plus 9, x times x minus 4, because this leading coefficient is something other than a 1. Now, had it been a 1, yeah, I could have gone x plus 9, x minus 4. All right, so now, what do I do with these numbers on the sides of the x? since my leading coefficient isn't 1 and I can't write those numbers in my factor. And this is what you're going to do. You're going to go back up. You're going to step 3. It says rewrite what? Your trinomial. How? By replacing the middle term only with the numbers on the sides of the x. So, and you're going to keep the first and last term in the trinomial. Okay, so this is the middle term right here. I am going to rewrite that. This middle term gets broken up into, instead of 5x, it's actually going to become 9x and negative 4x. So this middle term, these numbers on the sides of the x, I can just go ahead and put x's next to each one. So the 9 and the negative 4 now act as coefficients to rewrite the middle term. So because 9x minus 4x is this 5x. So I'm going to rewrite this. Keep the first. So you keep it. So you have 3x squared. Here you rewrite it. Break it up into the two numbers on the side of the x, which is a positive 9x and a negative 4x. And then you keep the last term, which is negative 12. Now this should look familiar because now you have 1, 2, 3, 4 terms. When you have 4 terms, you have to work your way back to factoring by grouping. So here we go. We all know how to factor by grouping. We're going to group them in pairs. All right, and I'm going to highlight. I'm going to group these two. And I'll do the GCF here. And then I'm going to group these two. And I'll write the GCF here. And then remember, we're going to be looking for some common binomial factor as well. All right, so let's do the block in yellow. So the GCF, undo, I need that to look better than that. The GCF between 3x squared and 9, well, they both, for the numbers, 3 and 9, the biggest number or the greatest divisor is a 3. All right, they also have x's in common. So I'm going to write the x. But now keep in mind, between x squared and x to the first power, choose the one with the smallest exponent. So it's 3x to the first power. Now, what do you do with your GCF? Well, you divide each of these terms in the yellow block by 3x, or 3x to the first power. And that's going to give us our remainder. So our remainder, these are going to cancel. And 2 minus 1 is just x. Here, these will cancel because they're exact. So you will end up with 9 divided by 3, which is 3. So your remainder is x plus 3. So now you take your GCF and you write it with your remainder so you can go in factor form. 3x times x plus 3. And now, since I have it written in factor form, I can move on to the blue block. Well, if you notice on the blue block, your leading coefficient is negative 4. So I know that the GCF needs to be a negative. So what's common between 4 and 12? Well, the greatest common divisors are 4. But because the leading coefficient is negative, I'm going to make it negative 4. Now, do they share any x's in common? No. So the GCF is just negative 4. So I'm going to divide by negative 4. Okay, negative 4 divided by negative 4 is positive 1x. Or you can say they cancel. I'm going to use a different color to cancel them out. You can say they cancel, which only leaves me with x. And then negative 12 divided by negative 4 is positive 3. So that's my remainder for the block in blue. Then all I do is write it in not standard form, but factor form. So my GCF is negative 4. So it's going to be negative 4 times x plus 3. Now I look for a common factor in this group and in that group. Well, what do you see? And it's a common binomial factor. Well, x plus 3 is here and x plus 3 is there. So your common binomial factor is x plus 3. So when I write this, I'm going to write it in factor form. I'm going to write my common binomial factor times whatever is left over, which is my remainder. So what do? I divide each one of these by x plus 3. And let me go back in so I can have some more room. Okay. I'm going to divide by that common binomial factor first. Divide by the common binomial factor, x plus 3. All right, and these are going to cancel. These are going to cancel. So I'm left with a remainder of 3x minus 4. Okay, that's my remainder. But what I want to do is take my common binomial factor and put it with my remainder to put it in factored form. So factored form for this one simply is x plus 3 times 3x minus 4. And that's that. All right, now let's take a look at number 2. Oh, that's not number 2. That was step 2. All right, so step 3, I did right here. And then step 4, also, this is all of this stuff down here. All this is step 4. This is all factoring by grouping, okay? All right, so let's move on to B. All right, let's take a look at B. Let's see if they have a GCF in common. So they have a GCF that's in common. 6x squared, negative 17x, and 5. Well, just look at 6, 17, and 5. Is there anything in common? No, nothing besides 1. This has an x. The first term has an x. The second term has an x. First term has an x. Second term has an x. But the last term doesn't have an x. So they don't have any variables in common. So what I want to do is go ahead with step 2. So step 2, I put a times c in the top of the x and b in the bottom, okay? All right, so a is 3, b is negative 17, and c is 5. So a times c, that would be, a is 6. I don't know why I said 3. A is 6. So 6 times 5 would be 30. That's my product that goes in the top. And then negative 17 is the sum that goes in the bottom of the x. So I know that the top number is positive. So that means that since the top number is positive, that means that I have 2 negatives or 2 positives that are multiplied to get a positive. Okay, but you look down here, this will tell you whether you have 2 negatives or 2 positives. Since 17 is negative, that means I have a negative times a negative that's going to produce 30. All right, so that's going to be a negative times a negative. Okay, now what will give you negative 30 when I multiply, but yet negative 17 when we add? And you can pause the video and think about it. I'm going to go ahead and work it. All right, so I know that negative 15 times negative 30 is positive, times negative 2 is positive 30. And negative 15 plus negative 2 is my negative 17. So the numbers on the sides are negative 15 and negative 2. Now I'm going to leave enough space because here I want to put an x. Here I want to put an x. Okay? Now, why am I doing that? Because now instead of the negative 15 and the negative 2 going in the factors, and you are writing x minus 15 times x minus 2, I don't do that because my leading coefficient is not a 1. Because my leading coefficient is something other than 1, then those numbers on the sides of the x are going to be used as coefficients of the x or the middle term to break it up the middle term. All right, so this replaces that middle term. All right, and what am I going to do? I'm going to keep this. Keep, rewrite, and keep. All right, so I'm going to keep the 6x squared. I'm going to rewrite negative 17x as negative 15x minus 2x plus 5. And some of you are probably saying, well, how do I know to put the negative 15x before the negative 2x? I don't care what order you put it in. You can put negative 2x minus 15x. And it probably would have been better to do that because negative 2x and 6x squared have more in common than 6x and negative 15x. If you look right here, negative 2x. If you look here, negative 2x and 5. Like the only thing they have in common would be a 1. And so I would have to use that. I'm going to work it this way, and then I'm going to back and rework it, showing you that if you regroup these or reorder these and put negative 2x minus 15x, it will look better, okay? But I'm just going to work it the way it's written to show you that it doesn't matter. All right, so let's do the one in, let me go back to the highlighter. We'll do this block in yellow. Then we'll put this block in blue. Okay. All right, so now let's look for the GCF in yellow. GCF, greatest common factor. Between 6 and 15, the greatest divisor is 3, and they both share an x, but don't choose x squared. Choose the one with the lesser exponent. And x is just x to the first. So I'm just going to go with just 3x or 3x to the first. You can keep the understood one if you want to. Divide each piece by 3x to the first power. So 6 divided by 3 is 2. And then 2 minus 1 is 1. So just 2x. Negative 15 divided by 3 is negative 5. And then just cancel these out because they're exact matches. So once I put the GCF with the remainder, I end up with 3x times 2x minus 5. And then in the blue block, the only thing they have in common is a 1. But the leading coefficient is negative, so I'm going to factor out a negative 1. So I'm going to divide by negative 1. Negative 2 divided by negative 1 is positive 2x. And 5 divided by negative 1 is negative 5. Now I'm going to put this GCF with this remainder. So I end up with negative 1 times 2x minus 5. Now you should see your common binomial factor. Your common binomial factor is 2x minus 5. So I'm going to divide each piece by 2x minus 5. These will cancel. These will cancel. And I'm left with 3x minus 1 as a remainder. And then I can write the final factor form with the common binomial factor of 2x minus 5 times the remainder, which is 3x minus 1. And I'm done. Now let me show you quickly if you would have reordered these. 6x squared minus 2x minus 15x plus 5. Then these two would have had 2x in common. That would have been the GCF. So you would have ended up with, the GCF would have been 2x for these two. Okay. All right, so you would have ended up with 3x, and all of this would have canceled, so you just would have put minus 1. So you would have had 2x times 3x minus 1. And then the GCF here is just 5. but the leading term is negative. So let me go back and say it's not just 5. Since the leading term is negative, it's negative 5. So when you divide, you end up with 3x minus 1. So I'm going to take my GCF and put it with the remainder of 3x minus 1. Now my common binomial factor is 3x minus 1. And my leftover will be 2x minus 5 once I divide each one of these by 3x minus 1. So as you can see, these two are the same, okay? Here the 3x minus 1 is first. Here the 2x minus 5 is first. But either way, you get the same answer. So you don't have to worry about, well, which one of those numbers do I put first when I rewrite the middle? Or which one of those terms do I put first when I rewrite the middle? Just put them down, and as long as they have something in common, you're good to go, okay? All right, let's look at the next problem. All right, looking at C, and I'm not going to do all of these because I think you get the idea of what I'm doing. C, does it have a GCF? No. So you're always checking for a GCF first. It doesn't have one. Not between all those. 6, 7, and 20 doesn't have a GCF. That has a B. The middle term has a B, but 20 doesn't have a B. So don't worry about there being a GCF. All right, 2, going to use the X method. The A times C X method is what I call it. Okay, I'm saying A times C and wrote it. All right. A is 6, B is 7, and C is negative 20. Keep in mind, we're going to do A times C in the top of the X and B in the bottom. So what is A times C? So what 6 times negative 20 is negative 120. And then B is 7. Okay. I know these numbers have to be different because I got a negative product. So I know I have a negative times some positive. All right, if I look in my denominator, it's a positive 7, which tells me the largest number needs to be positive. Largest number needs to be positive. All right, so I'm going to think about two factors that will give me negative 120, but yet add up to be positive 7. So I'm going to try 15 times negative 8. All right, so what is 15 times 8? So you have 15 times 8. That's 40. Kill the 4. That's your 120. And that's my negative 120. And then 15 plus negative 8 equals 7. So I know it's 15 and negative 8. But put your x's because these numbers on the sides of the x are acting as coefficients when you rewrite your middle term, okay? All right, so I'm going to use these terms to rewrite this term. Okay, I'm going to fix one thing. Anybody see what it is? So instead of having an x, what do I have? Well, I have a b. So let me erase this. So I don't want to put 15b, my x, I want to put 15b. Excuse me. And negative 8b. So you want to make sure you're using the same variables, okay? All right, now we're going to keep this, rewrite this, keep this. So we have 6b squared plus 15b minus 8b minus 20. All right, and then I'm going to factor by grouping. And group that and put the GCF there. Then I'm going to group these two, and put the GCF here. Then I'll find my common binomial factor. All right, so let's take a look at what we have. Between 6 and 15, the greatest common divisor is a 3. And then both of them have a b, but between b and b squared, choose b, the one with the smaller exponent. So I'm going to divide both of these by 3b, or 3b to the first power, so I can subtract my exponents. 6 divided by 3 is 2, and 2 minus 1 for the b is just 1. All right, 15 divided by 3 is 5. And these b's just cancel because b on the top, b on the bottom. They just cancel each other. All right, so I'm going to write this in factored form. This is my remainder. So I'm going to write it as 3b times 2b plus 5. Then I can work on the block in blue. Okay. All right, so between -8 and -20, I know both the leading term is negative, but the greatest divisor is 4, but I'm going to make it negative. All right, the first term has a b, but the second one doesn't, so the GCF is just -4. So I'm going to divide by the GCF. -8 divided by -4 is +2. So it's going to be with 2b, and -20 divided by -4 is +5. So this is my remainder for the block in blue. But I'm going to put it with my GCF. I have a GCF -4 times the remainder. And then I should see a common binomial factor. The common binomial factor is 2b plus 5. Excuse me. So I'm going to divide each by 2b minus plus 5. And some of you have probably gotten so good at this, you don't have to show the part where you're dividing. Because I already know I'm going to be left with 3b minus 4. I mean, that's a given as a remainder. You see what cancels out. This cancels and this cancels. So that's how you're left with the remainder of 3b minus 4. Now all you want to do is put your GCF, your common binomial factor, with that remainder. Your common binomial factor is 2b plus 5. And you're going to put it with your remainder, which is 3b minus 4. Okay, so this is your answer. And that's all you do. All right, let's take a look at another one. I don't know if I'm going to do D right now. I might want to go to something where I have a common, I'm going to GCF. Because I'm sure you get the idea of what we're doing. Well, let me do D, because D is different. All right. So on D, we have no GCF. So you're going to check to see if you have a GCF. Between 2, 7, and 6. Okay, nothing in common. That has an X, that has an X, but the third term doesn't have an X. This has a Y, that has a Y, but the first term doesn't have a Y. So there is no GCF common. So I can't factor out a GCF. All right, so now I'm going to do the next step, which is the X method. A times C and then B. So just put your coefficients up here. So here A, and that's the reason why I want to do this problem, is all running together with the other one. A is 2, B is 7, and here C is 6. I hope you all can see that. All right, so 2 times 6 is 12, and your coefficient here is 7. All right, so you're going to think, okay, I got a positive in the tops and a positive in the bottom. So that means I have a positive times a positive. That will have to be 3 times 4, which gives you 12, and 3 plus 4, which gives you 7. So you're going to use 3 and 4, okay? Now I need you to go back up here and look at something. Your middle term has an x and a y in it. Okay, just like in the example prior to, the middle term had a b in it. And what we did is we rewrote the middle with a b. So since our middle term down here on D has an x and a y in it, we're going to rewrite this over here with an x and a y, okay? All right, so let's do that. So I'm going to put an x and a y, an x and a y. So now this gets to replace this, okay? Just that simple. I know it has more variables in it, but you do it the same way, guys. Okay, back to the pen. All right, I'm going to keep this. Keep 2x squared. Rewrite this. So that's going to be, and I'm going to put the 4xy with the 2. Plus 4xy plus 3xy. 3xy goes better with the 6y squared. And you're going to keep that. Okay. All right, now I'm going to group. Okay, let's go ahead and group. There we go. This block in yellow with a GCF here. And then I'm going to do this block in blue with the GCF here. And then I'll get my common binomial factor. All right, so between 2 and 4, the GCF is a 2. That's the greatest divisor. Okay, I don't like that F. Okay, and then I see that each one of them have an x, but instead of x squared, I choose x because I'm choosing the one with the smallest exponent. So now I'm going to divide each one by 2x. That's a 1. All right, so 2 divided by 2 will cancel. That's 1. And then 2x is minus 1x. So I divide those powers. I subtract the exponents. I'm going to end up with just x. 4 divided by 2 is 2. These x's will cancel because they're exact matches, leaving me with a 2 and then y there. So when I put this with that, because that's my remainder, I end up with 2x times x plus 2y. Okay, now I'll move on to the block in blue. Between 3 and 6, the greatest common divisor is a 3. And this first term there has a y, and the second term has y squared. So let's just go with y. So I'm going to divide each by 3y. 3 divided by 3 is 1. They cancel. The y's cancel. I'm left with x. 6 divided by 3 is 2. And then as far as the y's, that's an understood 1. Subtract the exponents. 2 minus 1 is 1. So again, I have x plus 2y. Now I put my GCF of 3y, and it's positive. So put positive, put plus 3y. If it's positive, put plus 3y times the remainder of x plus 2y. Then I look for a common binomial factor, okay? So my common binomial factor, I'm shortening it, guys, because I don't have enough room to write it all out, is x plus 2y. So when I divide each piece by x plus 2y, these are going to cancel. This cancels, that cancels, this cancels, that cancels. So I'm going to see my remainder. I'm having to go up here because I'm running out of room. All right, so that's going to leave me with 2x plus 3y That's your remainder that's left over after you cancel out your common binomial factor. And then you're going to write it in factored form. Factored form is your common binomial factor of x plus 2y times the remainder of 2x plus 3y. And that's all you do. That's my factored form. All right, now I'm just going to pick maybe one or two more to do, because I think you should get the a good understanding of it. You should have one already. All right, I'm going to go down and work on I and J. I'll do those, okay? I'll do I and J. If you want to try the other ones, then you can just pause the video and then try these. Okay. Pause the video, try these two. And then pause the video and try K. And what I'll do is in a Google Meet session, you'll let me know which ones you tried and to check to see if you got them right, okay? If that's something you want to do. But I will have some practice on here. Matter of fact, I may let that just be your practice. Just do the ones that we didn't do. All right, heads up. All right, let's do I and J. So if we look at I, we're going to see if we have a GCF. We're always checking for the GCF first. All right, so you have 4, 10, and 6. Where is there a number that will divide into 4, 10, and 6? I hope everybody sees that 2 will go into 4, 10, and 6. That's the greatest divisor. And then I have an x squared and x, but over here I have no x, so I don't have any x's in common among all three terms. So the GCF is just 2. So what you have to do is, if you have a GCF, you have to go through and divide each one of these by this GCF. Anytime you have a GCF, go ahead and divide. So I'm going to divide by 2, divide by 2, divide by 2. All right, so that's going to leave me with a remainder of 2x squared plus 5x minus 3. And your GCF was 2. So this is what you're going to do. You're going to write this as 2 and then bracket 2x squared plus 5x minus 3. I'm going to use a bracket. Anytime I factor out a GCF first, when I'm factoring some other kind of trinomial or some other kind of polynomial that requires a different method to also factor, I'm going to use a bracket. So that 2 is my original GCF. Okay, that's my original GCF, guys. Y'all, hold on just a second.